Hello people, welcome back to our session. This is another session. We continue from where we left off from last time, where we were deriving from our transportation table. We were trying to derive a linear programming problem. Now, if you remember what I said last time is when we come, we shall continue looking at transportation models or problems. And specifically, I did mention that the next step from looking at how to derive linear programming problems from transportation tables, like what we are seeing here, is the northwest corner method. Now, there are different kind of methods that we can use to minimize or to find the basic feasible solution of our transportation matrix. Now, the northwest corner rule is one of those. So we have the northwest corner rule, we have the raw minima method, we have the column minima method, we have the least cost method, and then we have the Vogel's approximation method. Now, what is the northwest corner rule in brief? Now, the northwest corner rule is basically, if you are looking at the table on your screen right there, how it is stated, or the NW corner rule, how it is stated is we start with the northwest corner of our transportation table. Okay, let me grab my pen here. So we are saying that we start with the northwest corner of our transportation table, right? And then we consider the cell which is in the first column in the first row. Now, what are we saying there, or what do we mean by starting considering the cell which is in the first column and first row? Okay, now it's actually very easy if you think about it. Okay, it's very easy when you think about it. Now, I would draw a compass just right in the middle. I don't think this is the middle, but yes, it is the middle. So right in the middle, I'll draw a compass for us. Okay, I'll draw a compass something like this. Then of course we know we have the true north, as it is often called or referred to, and then I'm going to draw two diagonal lines like that. Okay, so this is our true north. True north. To the left we have the south. So up on your head, this is your head, it's your north. Your left hand is your west, your right hand is your east, and then your feet are your south. So south, then you have your head at the north. Okay, now the reason why it is called northwest is because this diagonal line here, this thing here you're seeing, the top part is called northwest. Down here, this is the southeast. Top right diagonal, this is our northeast. Then what do you call this? This is called our southwest. So southeast, southwest, northwest, northeast. Okay, and if you want, you can put those your northeast, you know, those things. You can put your east, southeast, your southeast, but we don't care about that. We want to derive a point home that will help you understand what the northwest corner rule is. So for our northwest corner rule, we are basically talking about this part here. Okay, now this is the northwest of our table. Now if you look at the table, the northwest will be the furthest point to your right, sorry, to your left. It would be, as we have said or mentioned, it would be your first column and your first row. Now corresponding to the first row in the first column, which is this one right here, we need to look at the values. Okay, the corresponding values. Now remember, this is the demand. Let me just label it quickly. So here we have the demand, and then here of course we have our supply, or you can say the production capacity if you want. Production capacity, and then you have the demand here. So these are the factories where the goods are coming from. These are the stores where the goods are being transported to. Yeah, so understand that. The warehouses and the stores there that we have. Now, corresponding to our northwest corner, we have the demand and the supply. Okay, we have the demand here and the supply here. Now the demand, the supply is labeled as A1. It can be A1, A2 and A3 since we have 3. Then the demand is our B1 and B2 and B3 and B4, just like that. Okay, now what you must do, or what you have to do, is compare your A1 and your BI, your A1 or your AI or your BI. You must compare, and if you discover that your AI or your A1 is greater than your B1, then you must assign the lesser quantity. In our case, the B1 is the lesser quantity in this cell. You assign it where? We assign it in this cell here, the northwest cell. Okay. However, if you discover that our A1 is less than the B1, then we must assign the lesser, which is our A1 in our case, in this cell right here. Okay? Or to put it in other words, we put the lower A1 and B1 as our first cell, which is called X11, if you remember what we did last time. Okay, now so the way we are going to do this is, let us read this question and then we can proceed to solving it. Yeah, now this question here, we have a company which has facilities at 7 places. Okay, and it has manufacturing plants at places A, B, and C. Then the output from our manufacturing plants are as follows. We have 500 units from A, factory A, warehouse A, from factory A or plant A, let's call them plants. We have 300 units being produced at plant B, and then we have 200 units being produced at plant C. Now it has warehouses at 4 places, and those warehouses are labeled as P, Q, R, and S, which are the daily requirement. They require, or they demand 180, 150, 350 and 320 respectively. Now the per unit shipping charges on different routes are given below. So these values we are seeing here, 12, 7, 6, 10, these values, these are called the per unit shipping charges. So these values mean that for you to transport a product from plant A to or warehouse A, from plant A to warehouse P, the cost of shipping is 12 kwacha. For you to transport a good, a product from, for example, plant C to warehouse S, the cost is 7 kwacha in that specific route. Now, how do we obtain the initial solution using this method? The first thing that we have to start with is we start with the cell which is on the intersection of A and P, the northwestmost cell. Now, the total raw total, or the supply, okay, the total raw total, this is a raw, okay, the total raw total is 500, and the column total down here we have 180. Okay, so remember what we said, we allocate the lesser one in the cell. So we are going to allocate 180 units in cell X11, the first cell here. So we can draw something like that, and then let's allocate 180 there. Now, since this destination, since this warehouse has been satisfied, or since we have satisfied the needs for this warehouse, now this warehouse demands, or it requires 180 units. Factory A, plant A, so they can produce and supply 500 units. Okay, it can produce and supply 500 units. So it will supply 180, just 180 units to warehouse P, so that it has been satisfied. So we cancel the 180, we put a 0 here, meaning satisfied. And then we need to subtract from 500. We subtract 180 from 500. Why? Because plant A has effectively supplied 180 to warehouse P. So what is 500 minus 180? So it's very simple. 500 minus 180 should give us something like 320. So 500 minus 180 will give us 320. So we are going to cancel this 500 here, so that you don't forget that you are subtracting. So cancel it, and besides it, just write your new amount, 320. And then also, once you have cancelled, let's also cancel this cell here, meaning we have satisfied it. Okay, now once we have satisfied that one, now what is our current new cell, or what is our new northwest? That's the terminology. What is our new northwest? It's very simple. Our new northwest is, we're going to move horizontally now. Okay, horizontally to cell AQ, this cell right here, and we're going to allocate also as we have allocated previously. So it will be the same method. We're going to do that. We compare between this and that. We discover that 150, the smaller one. Okay, so we're going to allocate 150 to this cell here, 150 like that, and then since we have allocated 150, we remain with 0 here. Yeah, so we are going to remain with 0 here. Then we cancel out this cell, then we cancel out this 320 also. It will remain what is 320 minus 150? 320 minus 150, 170. So this gives us 170 as our new amount, as our new figure. Okay, now we move to the next cell AQ, AR, sorry. We move now to cell AR. Then we allocate the smaller one 170 and 350. The smaller one is what? 170. So we allocate 170 here, which means this cell has been it's fulfilled its obligations to deliver. It has delivered all, it has supplied all that which it could do supply. Now, since it has supplied all that which it could supply, we now have the remaining 350 there. How do we do it again? We subtract 350 minus 170. So 350 minus 170 must give us 180. So we're going to cancel the 350, and we replace it with the 180, like that. Now, since this row has been fulfilled, it has delivered all that which it can deliver, we cancel everything remaining there, because plant or warehouse A cannot deliver anymore, because its delivery requirements are done. They are full. It has delivered all that which it can deliver. Okay? Yeah. Now, we come down now. So the next one now is BR. So BR, just down here, we need to allocate also, okay? So we have BR down there. So we allocate. What we allocate, we compare 180 and 300. We allocate the smaller one, so 180. So here, this has been fulfilled. Then we cancel like that, 0. Then we cancel everything on top, and then we have 300 minus 180, which gives us 120. So here we remain with 120. So once we remain with 120 there, we have two remaining cells, this one. So the northwest corner is 14, where there's 14 here. Okay, where there's 14 is our most northwest corner cell. So we locate the difference again, the smaller one. We compare 120 and 320, we locate 120. So this has been fulfilled, we are done. Then we come to the remaining one, which is this cell here, cell CS. Okay, so CS. So remember, once you locate your 120, you must subtract 120 from 320. So this will be a 200. And as you can see, the remaining values always, when locating, must be the same for the northwest corner. Okay, especially when and you see, I did mention last time that you must check if your problem is balanced. By balance, I mean your supply and your demand must be equal. So if they are equal, then when you do the correct or the right things, it must balance out at the end. So we have 200 here. That's our remaining allocation that we can make. Okay, now if you add these ones up, if you want, you can add 500 plus 300, that gives you an 800, and then 800 plus 200, that gives you a 1000. You can do the same thing also for the other side. 180 plus 150. Okay, so 180 plus 150, 330. 330 plus 350, 680. 680 plus 320, 1000. So our problem is indeed balanced. Okay, so this gives us the same exact amount. Now, once you have done that, you must go ahead and calculate the total cost Okay, the total cost that will minimize the transportation problem. So that is our next thing here. So we're going to say total cost is equal to, so total cost is equal to, what are we multiplying? The 12, the cost times the quantity allocated. So we can do the cost, which is 12 times the quantity allocated, okay, plus 10 by 150, 10 by 150 plus the next one is 8 by 180, 8 by 180 plus 14 by 120, 14 by 120 plus, what is the other one, 7 by 200. The last one is 7 by 200. Is it the last one? So we have 1, 2, 3, 4, 5. I think there's one remaining. So we've done 180. Oh, we forgot 170. Sorry, 12 by 170. So 12 by 170. So let's see, do the math there. So we can say 12 by 180 is 2160 plus 10 by 150, that is 1500 plus 8 by 180, 1440 plus 14 by 120, this is 1680 plus 7 by 200, 1400 plus 12 times 170 is 2040. So we add these amounts together. Let's add them quickly. I'm adding here. Okay, so the total is 10,000. So kwacha 10,220. So this is the total. Okay, so this is our total cost. So now this routing of the units meets all the RIM requirement, and it involves the total of how many shipments. That is the next question that we must be able to ask ourselves. Or in short, is it degenerate? Is it a degenerate problem? Okay, or does it meet all the RIM requirements, and does it involve the actual shipments? Are they occupying the number of allotted cells, if we can use the language loosely? Now, to check if your problem is degenerate or not, we mentioned that we use a very simple formula, which is row plus column minus 1. So how many rows do we have? Let's count the rows we have. We have 1, 2, 3 rows. Okay, we have 3 rows. So it's 3 plus how many columns? Columns we have P, Q, R, and S. Yes, P, Q, R, and S. Okay. So what we do now is we say 4 minus 1. So this must give us how many? 6 occupied cells. So if we count our cells here, the ones which are occupied, how many are they? Are they 6? So we have 180. So we have 1, we have 2, we have 3, we have 4, we have 5, and we have 6. So it means that our problem is not degenerate. Okay, Now, let me be very quick to mention that this method of obtaining the initial solution is probably one which is very simple, if not the simplest. However, it is also perhaps one of the most inefficient methods in terms of cost minimization. Okay? Why? Because this method takes into account only the available supply and demand requirements when we are making our assignments, and it does not take into account the shipping costs which are actually involved. Okay? So it ignores the very factor that it must be able to minimize, which is the cost. Yeah. Now, this is the easiest, but one of the most inefficient ways of finding of finding a initial feasible solution. So this was it about the northwest corner rule, and this is where we end our session for today. Thank you very much for joining us, and we're hoping to see you in the next session. God bless you all.